Okay, after discussing Coulomb's law in magnitude as well as in vector form, let's discuss some numericals based on that. Let's start with the very basic numerical. Let's consider a system comprising of 4 similar point static charges placed at the 4 corners of a square of side A. And for convenience, again, let the charges under consideration be positive. Now, a charge Q0 is placed at the center of the square. Now, if we are asked to determine the net force acting on charge Q0 due to the presence of other charges around its vicinity, then how to go about it? Again, force, we are trying to calculate the force. It's a vector quantity. And in order to solve in order to find any vector quantity, we need to make use of laws of vector addition only. So method is, this is the point center. Center means intersection of the diagonals, isn't it? Intersection of the diagonals. So at this point we need to calculate the net force experienced by charge Q0 due to the presence of all the other charges. So we'll make use of principle of superposition. So first point is the point where the net force is to be calculated, mark it by point O. And rest of the charges you can put numbers 1, 2, 3, 4. So as per the principle of superposition, the net force at point O experienced by charge Q0 would be given by the vector sum of the forces experienced by charge Q0 due to all these individual charges. That is F01 vector plus F02 vector plus F03 vector plus F04 vector. This is principle of superposition. So the net force experienced by a charge due to the presence of all the other charges around its vicinity is given by vector sum of all the forces exerted by the individual charges on that given charge. So let's solve it. First and foremost, this is the point where the net force is to be calculated. Let's draw the vector diagram first. Consider these 2 charges, 1 and O, Q1, Q. Both are like charges. For convenience, it is to be considered as positive as well. Both are like charges. So obviously, this charge will get repelled and it is a central force. So it will experience a force along the line joining these 2 charges. So it will get repelled like this. So it may be written as F01. It is the force experienced by charge Q0 due to charge Q1. Charge Q1 will also experience the same force along the same line but in the opposite direction. But you need not to draw that vector over here because our main objective is to find out the net force at the center of the square. Net force experienced by charge Q0. So this is done. Now second, this is again charge Q, this is Q0. Both are like charges. So this charge due to charge Q placed at point 2 will again experience a repulsive force. And since it is a central force, it will act along this line only. So this is F02 vector. Similarly, like charges, so Q0 will also experience repulsive force due to this. It will get repelled from charge. So this is F03. They will also experience the equal and opposite force, repulsive in nature, but we need not to draw that. We need to draw the vector diagram only at a point where the net force is to be calculated. The fourth one is left, the charge at point 4. Again, like charges, so Q0 will experience a repulsive force due to this charge placed at point 4. So it will experience a force over here. This is F04. Now look, magnitude of F01, F02, F03 and F04 all are equal, F same. Why they are equal? Because the pair of charges, magnitude of the pair of charges is same and the separation with them is also same. The distance of point O from each of the 4 corners is same. So that is, one of the magnitude is Q, the other magnitude of the charge is Q0 divided by 4 pi epsilon. Suppose the distance is R between the pair of charges. So it is R square. So magnitude of each of the forces is same. Q0 divided by 4 pi epsilon R square. Right? This is the magnitude. Once you have represented the vector diagram, we need to consider the magnitude. Now consider these 2 forces. They are equal in magnitude, opposite directed, so they'll nullify the effect of each other, isn't it? I'll represent it over here. The magnitude of F04 is F, the magnitude of F02 is also F. This is F and its magnitude is F. All the forces are of equal magnitude. Now, these two are of equal magnitude, opposite angle, so they will tend to nullify the effect of each other. Similarly, these two forces are of equal magnitude and opposite angle, they will also nullify the effect of each other. So the net force experienced by charge Q0 at the center due to the presence of all the other charges is 0. So this is how you need to solve such questions, by making use of laws of vector addition. Let's consider some other example as well. Let us consider this to be an equilateral triangle, each of side A, and charges of Q are placed at the corners. Question is, you need to find out the net force experienced by any charge placed at the corner. Any charge, you can consider any charge. Suppose this is a charge where the net force is to be calculated. As I have suggested, denote it by 0.2, and the other charges, do the numbering, right, from 1, right? Now, this charge will experience an electric force or repulsion due to charge at point 1, so it will experience a repulsive force due to this charge, repulsive force. So it is central force, so it will act along this line only. This will be F01. It's okay now? It will also experience the same repulsive force along this line only, but you need not to represent it. You need to draw the vector diagram at that point where the net force is to be calculated. Okay. Now consider charge Q placed at 2. These are also like charges. So this charge under consideration will get repelled from charge placed at point 2. So since it is central force, it will act along this line. So it is F02. All the sides are equal, so it's an equilateral triangle. So each angle is 60 degree. So this is vertically opposite angle, so this is also 60 degree. Now it's very clear. The magnitude of F01 and F02 is equal. You can easily check. Pair of charges is Q, 1 over 4 pi epsilon, and distance between them is A square. We'll consider the charges to be placed in arrow vacuum. So the magnitude of F01 is equal to the magnitude of F02. No point in that. I mean, each is considered to be F. Now the resultant of these two. Remember, we need to solve it by making use of laws of vector addition. It's a vector quantity. So we are aware if the two vectors A and B, right, they're inclined at an angle theta between them, then the magnitude of the resultant is given by square root of A square plus B square plus twice AB cos theta, isn't it? So over here, the resultant would be given by A square over here plus B square, again magnitude is F, plus 2AB and the angle between them. Cos 60 is half. So it would be F square plus F square. Cos 60 is half. Half and 2 will get cancelled. So we'll get 3F square. So resultant would be root 3F. So it is root 3. F is Q square divided by 4 pi epsilon A square. So the magnitude of the resultant force is root 3 Q square over 4 pi epsilon A square. This is the resultant force. This is not the end of the solution, because we need to calculate the force, which is a vector quantity, and this represents only magnitude. You need to mention the direction of the resultant force as well. So this is the magnitude of the force experienced by charge placed at this particular point. Now what about its direction? Now again we are aware, if the two vectors are of equal magnitude, then the resultant always bisects the angle between them. You need not to prove it again and again. Here you need to write the answer directly. So these two are of equal magnitude. Therefore the resultant, as per the parallel law of vector addition, it will be given by this. This is the direction. It will bisect the angle between them. So this angle would be 30 degree and this angle would be also equal to 30 degree. So this is the direction of the resultant force. So I hope you have understood this question. So similar questions can be attempted by your